chiplet still a challenge with the UCIe 2.0. New connectivity standard brings performance improvement and a bunch of new features, but it may take years before they are adapted and still may not result in an open chiplet market. Plug-and-play chiplets are the popular goal, but does UCIe 2.0 move us any closer to the becoming a reality? The problem is that the current drivers of the standard are not after interoperability in the way that plug-and-play requires. Released in August 2024, UCIe 2.0 touts higher bandwidth density and improved power efficiency, as well as new features supporting 3D packaging, a manageable system architecture, and more. The standard is driven by key industry leaders, including ASE, Alibaba, AMD, ARM, Google Cloud, Intel, Meta, Microsoft, NVIDIA, Qualcomm, Samsung Electronics, and TSMC. But what is required at the leading edge may be different than what is required for the rest of the market. The standards are being driven by the data center guys, and the associated files are the targeting leading edge nodes, which add to the complexity, said Kash Johar, founder of UCIe. For the rest of the world market, which is a lower cost device targeting 28 nanometer down to 12 nanometer, people just want to standard building blocks and to those together using an FPGA or an AC. There is a more of a need for a standard at the lower end. These customers really earn the reusability. If you're designing the bleeding edge, the pointless to limit yourself with an old standard. So, who exactly is the standard for? For applications in data center and AI accelerator sectors, UCIe will establish itself as a standard, said Andy Heinich, head of efficient electronics in Fraunhofer IIS, engineering of adaptive systems division. For other applications, well, the challenging is to build cost-effective, robust chiplet solutions. It's unclear whether UCIe is the right standard. In this case, further extension or modifications or even different standard will be needed. Within the data center, nobody is looking to a third-party chiplet market. Standards like UCIe are useful as a baseline architecture and baseline set of features that you can adapt when it doesn't stand in your way, said Elad Aron, CEO of Blue Cheetah. As soon as there is a knob you can turn that enables you to achieve a better cost of power, you turn the knob because you're not really giving up interoperability. You are just gaining some benefit to the end product. The hope is that a benefit of the world standard spread out across a large market for captive chiplets, where both sides are designed together. UCIe 2.0 ensured streamlined in-house integration, said Mayank Bhatnagar, product marketing director for a die-to-die interface IP in Cadence Silicon Solutions Group. For third-party ecosystems, its standardized interfaces and test and debug features promote seamless interoperability across the vendors and driving broader adoption. So there continues to barriers to making broad adoption possible. For marketplace to thrive, there needs to be a more interoperability, said Mick Posens, Vice President of the Product management for high-performance computing IP solutions as synopsis. This is still an emerging technology. Over the past year, we have seen the introduction of new package technologies. If you look at the high-performance compute, the packaging technology has not converged. You've got a EMIB and CoWoS technology. Each of these, each of each of those is racing to offer differentiated across each other, but technically they have not converged. While die-to-die specs have matured and access to technology has become easier and you can't mix and match. What's used for 2.0? There are several areas in which standards has advances. There were a lot of very good things that UCIe 2.0 has gone that blew cheaters along. The 3D part of it was very well done, fleshing out of a lot of the details, expanding the range of footprints and configuration. It's moving in the right directions. And while new people are yet tackling it through true 3D chips, there will be a long-term benefit. UCIe 3D is brilliant from the interoperability standpoint because the channel almost doesn't exist, said your chips Johal. One die is talking to another die. The file is trivial. It's basically on an inverter, so it's as close to being within the same chip as possible, even though it's two chips. There's no serialization. There's no training, no DLL, no equalization. None of this sexy stuff that takes power. It'll take a few steps to get there. UCIe 1.1 offers interoperability at the PHY and a die-to-die layer, but not the software and management layer, said Luis Rodriguez, engineering site lead with achievements due to their industry software. Most of the UCIe 1.1 projects are single die to single die. UCI 2.0 with the system architecture and management layer should allow for complex topologies and a standard way of managing, debugging, and running diagnostic tools on a packaging that had complex UCI topologies. Others agree. Let's say you have multiple chiplets within the system that snaps this Posner. The system needs to come up and there needs to be a protocol that runs across either the main band or a side band of the UCI to manage the bring up. You're gonna have one of the dies within the system that is gonna be the orchestrator of the system. Maybe it's the one where you have your name testability port with that a JTAG or something. Until UCI 2.0, there's no standard definition of the protocol to manage the system, but it goes further than that. It also wrote about testability, where you may have a die that fundamentally only has a UCI interface. How do you manage testability with your system? They define the system capabilities that are outside of the scope of the physical protocol, but specifying how there is interaction across either the main interface or the sideband interface. Not everyone is a fan. There are other ways of addressing many of those same considerations that have some trade-off in terms of overhead and invasiveness relative to the functionality you're trying to get, said Alan. Today, everyone has different ways of doing these things, and they are all optimized for slightly different use cases. But standardization offers other advantages. UCI 2.0 is a thinking ahead as far as the management layer, offering a standardized way to manage chiplets and a look at things like the DFX, so test and debug, said Jimenez Rodriguez. This opens an opportunity for not just the chiplet vendors to develop software, but for EDA vendors to develop additional tools for testing those chiplets. I don't think companies will be able to just slap it onto the package. They will do testing of these chiplets standalone and UCIe 2.0. The management and the DFX additions allow the full of companies to be able to do that in a standard way. All parts of the development chain needs to be considered. The advanced manageability features and protocol enable precise memory access and efficient communication with the multi-chiplet systems, said Mackenzie Rose, Vice President of the Marketing for Smart TV. By addressing the complexity of the system, integration, and lifecycle management, UCIe 2.0 simplified the adoption of chiplet-based architectures as it established itself as an emerging standard for logic chiplet. Thorough the verification becomes imperative to ensure the compliance and reliability. The promise of the plug-and-play chiplet. Today, chiplets remain at the cutting edge, available only a few that account for the cost. Over the past year, we have seen a 2 or 3 announcements of chiplet that you could potentially buy off shelves and include in your packaging, along with your custom logic, said Rodriguez. As we see projects taping out in 2 years in that adapt to UCI 2.0, the whole idea that you should be able to reduce the complexity of your own project and buy off-the-shelf chiplets for things like adding an FPGA, adding AI accelerators, adding memory into your package, and then only worry about integration and managing those different templates. But it is early to make that call. There also has to be a compelling reason to do it. The dirty secret of the multi-die is that additional complexity, said Postner. The value of a multi-die is so high that companies are willing to take on a complex to solve a number of issues. It could be practical limits that they are hitting. It could be they want to do compute scaling. They are willing to take the additional complexity. Our goal is to continuously evolve our deliverable to enable that in more seamless fashion. It's not just an IP at the point. It's gonna be tooling, ecosystem, flows, reference designs, all the way through the potential references for the whole chiplet. While UCI tackles how two dies communicate, other issues remain. Defining the integration is attempting to cart before the horse, said Allen. Even where we solve the problem in its entirety, it still will not necessarily give us plug-and-play chiplets. You're not gonna get a plug-and-play and interoperability at the chip level that is independent of the interfaces. Issues exist at the multiple levels. The UCI 2.0 standard is a step forward in the right direction to provide a more complete integration platform for the covers electrical, fine protocol layers, as well as testability and manageability. How the two dies interaction between each other, how we test it, how we load the firmware. That is Sony, Kapoor, a product marketing manager at Alpha Wave Semi. Unlike other initiatives in the industry, will be the SOC infrastructure determines to develops all these aspects as custom solutions. The UCIe standard is the first in the industry to combine them. The new specification provides a good platform for system in packaging users to adapt and configure for their specific disaggregation needs. Unlike other initiatives in the industry, where the associate infrastructure determines and develops for these aspects as customer solutions. The UCI standard is the first in the industry to combine them. The new specifications provide a good platform for system-in-package users to adapt and configure for their specific disaggregation needs. However, there is no standardization for the protocol layer using streaming mode. Current chiplet designs need a low latency method for data packetization, which is left often to other industry ecosystems to pick it up and optimize for specific applications, Kapoor said. This gap leads to a proprietary solution that optimizes the die-to-die data path for low latency, low power, and high bandwidth. We are also excited to see new initiatives like the one promoted by ARM to extend their AMBA protocol family to support coherent C2C, also new D2D specifications that adapters can use. And we can think more examples like this will be using UCIe file layers as a base for a new protocol application specific to be layers in. Packaging has other challenges. With advanced packaging like HBM, it really can work, says Johar. It's a simpler channel because it's only 2 millimeters on the interconnect side. This is where the real world is terms of high performance data center guys. For them, the cost doesn't matter. Even though it's easier to achieve interoperability with advanced packaging devices, people can't really use them in the commercial market. And it's not as easy as buying a 5-foam salmon and then boom, I put my chip together and I will be able to a chiplet that people can buy. There are huge issues with the packaging as well as interoperability. Complexity is present at every stage. There is a physical definition of how the chips are gonna interconnect with the TS visa, and all these physical packaging issues that people are trying to solve, said Mao Wang, Senior Director of the Product Management at QuickLogic. There's also the logical interconnection between the chiplet. If we have a chiplet from a vendor A and chiplet from vendor B, how do you ensure these two can communicate using FPGA-based chiplets solve the problem? Now you have the ability to define whatever protocol you want to have above the UCI physical layer. We will be able to communicate to no matter how you want to send your data from one chiplet to the other. This is important, especially as we are looking at more mainstream market. We would benefit from the chiplets. Someone has not defined what chiplets look like physically. OCP has the open chiplet economy. Effort is trying to define this chiplet socket, said Alan. The other event that has drawn attention was the notice of the founding fundamental opportunity that was put out by National Advanced Packaging, funded by the U.S. CHIP Act. A component of that is to define the specific chiplet. They want to know what those are, how they fit together, what they do in your system design, what third-party devices could what third-party devices could you plug in for those specific places? The attractiveness of the plug-and-play vision is strong enough that there is a reasonable amount of discussion and a lot of effort around trying to make it happen. Cost remains a big barrier. There's another standard called bunch of wires, BOW, which can target standard packaging, and that it is the way to get started with the chiplets, says Zohar. They can drive a channel length of about 10 millimeter to 15 millimeter without termination, and up to 25 millimeter with termination. If you take a 64-bit link that is a point-to-point connection, you need a 64 receiver links, you need a 64 TX. It's a whole host of pins, and if you have a 130 millimeter pitch, if you're looking at a 6 millimeter square per link, that a link has two of these, it's not viable from a cost standpoint. The other challenge is that for length to work, the signal integrity and power integrity becomes very problematic. If you have a good long link, which everybody likes, even with the file from the same vendor but a different node, to get that to work with those long reaches with different material, it's a mess. Partnerships are forming to help solve some of these issues. Organic substrates are more unified because it's more mature technology, but it's not applicable to a lot of high-performance computer scaling. Said partner, it does offer the bandwidth density. It's very focused on a closed ecosystem because everyone in that ecosystem has to be aligned for it all to a mix and match. That situation exists for automotive. This mini ecosystem building, while the supply chain view is enclosed, the barriers to multi-die is lowering, and that's because of maturing of the technology, a maturing of tools and ecosystem IP that's available, but also abundant now of expertise and references. We'll get a point where best practice will come into place. Other contenders. Closed ecosystems also allow for more specialized solutions. UCIe is well suited to many chiplet applications, although some applications with asymmetric traffic such as sensor and memory may require more specialized interconnect schemes, said Kevin Donnelly, Vice President of the Strategic Marketing at Elan. A standard-based approach will be a key to enabling an open chiplet economy and marketplace in the future. Since today much of the chiplet implementation is being done in captive fashion by large early adopters, more specialized and optimized interconnect will likely continue to be used in the highest volume applications. While UCIe may address the needs of the existing user base, it does not cover everything. UCIe does not address all of the needs of all markets, said Jimenez Rodriguez. We will see other competing solutions. For example, Bunch of Wires is currently working on defining a memory-specific mode, which UCIe is not addressing. Bunch of Wires is a lot of customizable and serve the needs of captive chiplets, but UCIe is a way ahead of in terms of fostering interoperability for an open chiplet marketplace. If you need different bandwidth requirements or asymmetric bandwidth requirements, then UCIe does not address these problems. UCIe is attempting to ahead of the needs of the market. It was released early. Compared to our experience with our standards like PCI Express, said Ed Rodriguez. They released a final version of UCIe 2.0, and we are just starting to see a few projects implementing it. with PCI Express. IP companies will start implementing IP from a 0.5 revision of the spec. UCIe seems to have taken the approach of creating the spec and releasing it before adoption. There is a danger that is not addressing the right needs. I believe the chiplet will end up with sockets and people defining them very carefully, specifically for their own individual use case, says Alan. It is somewhat unlikely that anything that is sophisticated is really needed in the vast majority of cases. For most cases, the extra overhead is a headache. I'm saying this is more about the system management to put up a few 100 pages of the spec. Missing the point. Will UCIe enable an open chiplet marketplace, or is it only addressing the need for existing adopters? That is a question about the advantages that chiplets may present to the mainstream market. Users can afford chipset-based design today because they need to push more computing, more I/O bandwidth, and more memory bandwidth, said Alpha Wave Semi-Copper. Chiplets are not for everyone. UCIe does a good job for us segmenting the market and offering solutions based on low-cost standard packages and high-end but advantage packages, introducing an option for an even more expensive systems like 3D in the 2.0 versions. There is a misconception that a UCI creates overhead, and if you want to comply with all standard expectations, your D2D system is not optimized. On the 5 layer, there is no magic, and you need to address the packaging channels, and the standard UCI standard do a very good job of optimization the 5 layer to layer for each of those cases from form factors. There is more work to be done before chiplet can be pulled from a commercial marketplace and plugged into design. The whole point of a chiplet concept is that medium-sized companies, which are able to chiplet have proven, can reduce their cost, said QuickLogic's Wang. They want to create something that is unique without having to build an entire ASIC from scratch, which would take them much more longer with a higher development cost. Cost remains a big barrier for starters from a technological perspective and even volume cost perspective, and might make sense for them to be a chiplet style of design, says Alan. That does mean that they need multiple mask sets, multiple tape out, compared with the initial NRE of that to a large monolithic chips in an advanced node, and it's not a simple trade-off. There are cases where NRE getting your first product could be lowered by sticking to a monolithic solutions. It's a complex dance, and this is true of many things in engineering. The things you would do in a steady state. Once you've already got a large enough market, a large enough business may be different than what you have to do to enter. The likely will change in the future, but not today. If you are a medium-sized company and you're looking for a chiplet from 1 or 2, 3 vendors, you probably don't want to go into super advanced packaging, says Wang. That is gonna be it up most of your costing, and you might as well just go build an AC. Okay, today I read this article, Chiplet still challenging with the UCI 2.0. Thank you for your time. See you next time.